Okay, good morning. So let us start the lesson. So if you remember, we started talking about primitive functions last time. So what is a primitive function? When I say, if I give you little f and I ask you to find a primitive function of this, let us say this, what do I mean? So usually a primitive function of little f is denoted by capital F. So what is the meaning of capital F when I say f is a primitive function for this f?
Means that capital F prime is equal to
Yeah, so it means that when I ask you to find a primitive function for f, by the way, another name for primitive function is antiderivative. It's a good word because it's opposite to derivative, yes? Because I saw some English translation in national exam, they are using the word antiderivative. So antiderivative is the same as a primitive function. So when I say find a primitive function or an antiderivative of little f, it means I am waiting for you to give me a function whose derivative is little f. And then we learn that there are infinitely many functions. If you find one of them, there are suddenly infinitely many of them. But the good news is that they are not totally different. They differ at most by an additive constant. So this is why we have this C at the end of these formulas. So these are the formulas we had before. So if I have a constant, the primitive function is the constant multiplied by x plus an arbitrary constant c. If x to the power of a, we learn that this becomes a primitive function for this. Is this what you see on the board? And this only works if a is not minus 1, which was in Math 3c. But what happens if a is minus 1? X to power minus 1 is 1 over x. This is Math 4.1. So that is ln of x. So these three formulas we had, and then I told you that there are two generic rules, that if you have the sum of two functions and you want to find a primitive function, you can do it separately. And if it is addition, you add. If it's subtraction, you subtract. And if you have a constant multiplied by your function, if you want to find the primitive function, just write the constant and concentrate on finding a primitive function from the function. The last thing that I told you, this is not in the formula sheet directly, is that this combination should look familiar to your eyes. Sometimes they design questions related to this, and that is that you have a fraction whose numerator is the derivative of its denominator. So if I ask you what is a primitive function of this combination, this becomes ln of the denominator, of course, if you want, plus a constant c. Yes? And now, this warm-up problem, I saw this in E-level question in the book, so it motivated me to start with this one, and then I made it a little bit harder in this one. So let us solve these two problems. So this is an E-level question in the book. I don't exactly remember these two numbers, but this is very similar to this. So what should I do for finding a primitive function to that? Yes? Any ideas? Yes?
can split up so 3 divided by x plus 3 divided by
No, this cannot happen. Be careful. So let me write this and cross it over. Some of you might still think that this is the case. Yes. So I told you that if you have a plus b divided by c, you can write a over c plus b over c. And of course it is minus minus. But if I have c over a plus or minus b, I cannot write c over a plus or minus c over b. Please write and cross it over because that's not correct. Okay? So what should we do now? Yes?
Write 3 times 1 divided by x plus 6.
Mm-hmm.
And then later on replace 1 with
The
x
derivative.
plus 6 derivative.
Exactly. So that's the same idea. I just wanted to give you some examples about this because this is a little bit non-trivial problem in Math 4. So here I have a fraction. So if you have a fraction whose denominator is one expression, then probably you should use this rule, that we solve some problems using that. But if you have one element there and more elements, one term up and more than one terms down, then you cannot split them. then it might be an indication that this rule is applicable. I'm not saying that 100% that's the case, but at least you need to think in this way, that if you have a fraction of this form, what you might be able to think about is that formula, the last formula down there. And what Samir said is correct. So what we do, I would say that f of x can be viewed as 3 times 1 over x plus 6. Yes, that's the same thing. But now this 1 can be viewed as x plus 6 prime. Yes, because x plus 6 prime, the derivative of x is 1, the derivative of 6 is 0, so that's 1. But you might say, what is the benefit of doing this? And then you understand what is the benefit, because this combination that appears is exactly the combination u prime over u. Yes? So by giving the role of u to x plus 6, then this becomes u prime over u, which is exactly the combination that I need. And I'm not worried about this 3, because 3 is a multiplicative constant. So if I want to find, and here I have mentioned all. Do you remember? We talked about all, a, and all, and today I want to talk about the article de as well in these two problems, okay? Okay, so now if I want to find all primitive functions, so I write capital F of x is equal to, this is multiplicative constant, and primitive function for this combination is this, which I told you it's not in the formula sheet. So what happens? It becomes ln of x plus 6, but because I am emphasizing I want them all, so you have to show respect to it and add your constant. Yes, so that was E-level question in your book. Yes, understandable? Okay, but now I try to use the same idea to design a little bit harder one, but the idea is the same. So I want to do the same thing here. Do you have any ideas what to do?
Replace -1 with +2 -3 above on the numerator.
Yeah, exactly. So what he is saying is that let us write this. So g of x is equal to, I would write 2x. This is -1. What he's suggesting is that let us write +2. But of course I cannot change the problem. I have to solve the problem, but my teacher told me yes. So to compensate for that change, what should I do? I should write -3, okay? You might say why this is useful. You have to be a little bit patient to see. Yes? Okay, anyone? Do you understand why this should be useful except Samir himself? So first of all, do you agree this is true? Because 2 minus 3 is the same as -1. Okay, why this is useful now? No clues? Because you can factor a 2 out. Okay, tell me then. I wait for you again.
You can factor a 2 out and then write, and then you can split the whole.
Now you can split. Yes, because now you can give the role of this expression to A and give the role of 3 to B with minus sign, and give the role of x plus 1, give the role of C to x plus 1, sorry. Okay? So then you can say A over C minus B over C. So I can do it like this. I can say this expression divided by x plus 1 minus this divided by that. Yes? So this is an experience. I mean, you might say that how should I know this? First of all, because Samir did it, it is possible sometimes. And then another thing is that you have to put this in your toolbox. You know, that's how it works. Okay, so then what happens? Everyone probably sees that this one and that one are cancelled. So what do I have? I got 2, and then I have minus. This is the same problem, more or less, except that instead of 6, I have 1. So what I would write 3 times 1 over x plus 1. Yes? Now I start finding the primitive function. One more step is, hopefully you know what to do. 2 minus 3. What should I write for 1 now? U prime. So it's x plus 1 prime over x plus 1. Now everything is ready. I want to find capital G because the name of my function is little g. So let me use capital G for its primitive function. So capital G of x is equal to, which formulas are involved? Here I have the difference of two functions. So this formula with minus sign is applicable. Okay, so I have to find a primitive function of 2 and a primitive function of this combination. But what is a primitive function of 2? This is the first rule. Yes, a constant, its primitive function becomes constant multiplied by x. So this becomes what? 2x. Yes? And then a primitive function for this is this formula first. I don't consider the multiplicative constant, so I write minus 3. But this is this formula. So this becomes ln of x plus 1. But because I have asked find all primitive functions, you have to add this constant at the end. Yes? Okay. Before completing that table, my goal is today to complete this table. But before doing that, do you remember I told you that sometimes they ask you find a primitive function? It means that you have to choose something for C. The best choice is to choose 0 for C. Yes? Sometimes they ask you about finding all primitive functions, so you have to show respect and put this capital C at the end. Sometimes they ask you to find the primitive function. If they ask you to find the primitive function, they have to provide you with extra pieces of information so that you can use that piece of information to determine the exact value of this constant C. Yes? Okay, so what should we do now? Here, let f of x be equal to this function as you see. This is today's lesson. Determine the primitive function, capital F of this function. You see, it is not finished, such that an extra piece of information is also provided. So what should we do? So you find all primitive functions of this. This is the solution to this example. So before doing that, I have to write f in a way that I can find its primitive function. This is in a good form because I can use the second row in my table. But the square root of x is not in my table. So we had a lot of exercises like this. So what should I do first? So I write 3x squared and plus 2 times what? X to the power of 1/2. And then I have a constant c. Now everything is ready to find all primitive functions. So I would write capital F of x equals to. So this one, what is the answer to this one? I hope that you can do it in your head now. Yes? So what is the primitive function for 3x squared? X cubed, yes? Because the derivative of x cubed becomes that. But here, let me write it down once more. So 2, I give the role of a in the second row to 1/2. So it becomes 1 over 1/2 plus 1, x to the power of 1/2 plus 1. From now on, I really skip these simple calculations. I will do them in my head, okay? And then 1 is x, but you have to put a constant c at the end. So let me simplify this a little bit. So capital F of x becomes equal to x cubed. And then what happens here? 1/2 plus 2 is 3/2. So 2 goes down. So it becomes plus 4 over 3. X to the power of 3/2. And then plus x. And then plus c. But this is not the primitive function. This is all primitive functions. But I want to determine c in a way that it satisfies this condition as well. So using that extra piece of information, then I can find the primitive function. So what should I do? I say that, okay, you are telling me that f of 4 should be 3/2. So what does this mean? So this means that if you go to f, replace x with 4, the output should be 3 over 2. So let us do that. I go here and replace x with 4. When I replace x with 4, I get this, but I know output should be 3/2. And then I have to solve this and find my unknown c. Okay, so how should I solve that? 4 to power 3 is what? 64. 4 to power 3/2 is 8. Yes, because 4, 2 to the power of 2 to the power of 3, 2. Then it becomes 2 to the power multiplication 3. This becomes 8. So this is 8 times 3 times 4 is 32 over 3. And then I have an extra 4. And then I have a c. And then I have 3 over 2. So you have to solve this and find the answer. Yes, it's a little bit annoying, but we have to do that, okay? So what should we do? I take the common denominator. 64 times 3 is how much? 192, and 12, 204. And this one is what? 236 over 3 is plus c is equal to 3/2. So I move this number there, and then I simplify this. So what is c? 3 over 2 minus 236 over 3. And of course, if I take the common denominator, is 6, that is 3 times 9, that is 2 times is 472. So what is that number now? Minus 463, am I right? That's it. Okay, and then you have to write this as the answer. So sorry for the numbers. The numbers are not. I hope that you are not. I'm not distracting you. But the point is that you find the all primitive functions. You use that piece of information to find c. And when you find c, don't leave it. Especially in the national exam, you have to write this. So f of x is equal to what you see on the board with this c that you found. So this is x cubed, and then plus 4 over 3. X to the power of 3/2 plus x minus 463 over 6. And I hope that I haven't made mistakes in my calculations. You can check them later yourself. But hopefully you understand what is the meaning. So when they say there, always look for an extra piece of information in the problem. So use that to fine-tune your constant c. Okay, I want to wait for you a little bit for this one. Okay. Unfortunately, I forgot to record this part, but anyway. So these are two formulas we add. We had both of them in Math 3C. So this is the only new one. Okay, so now, for example, let me ask you a question like this. Example, determine a primitive function. If you don't mind, let me this time write antiderivative so that you also get used to this word. Determine an antiderivative. So number one, f of x equals to e to the 3x minus 2e to the power of minus 2x plus x minus square root of 2. Okay, so what is a primitive function for this? Yes, you know the rules. Yes, we have the difference and the sum of some functions, so I can do them separately. But these two are the new, is this formula. Yes? So what should I do? Primitive function becomes what? Capital F of x becomes. Here, this is k, so it becomes 1 over k. So it becomes 1 over 3, but the function repeats itself. Yes? And then I have minus 2 times this one is again this new formula, but this time k is minus 2. So 1 over k becomes 1 over minus 2. And then the function repeats itself. But this one is the very famous simple one. It is 1 over 2x squared. I don't repeat it. What is minus the square root of 2?
Minus square root 2x.
X. Because minus square root of 2 is constant, so it becomes minus square root of 2x. But because I have written one primitive function, so you don't need to write the constant. So I would prefer to simplify and write the final answer as 1/3 a to the power of 3x. This minus 2 and minus 2 are cancelled, so it becomes plus e to the power of minus 2x. And then I have plus 1 over 2x squared, and then I have minus the square root of 2x. Yes? So this is essentially a math 3C problem. So number 2, for example, f of x is x to the power of pi plus pi to the power of x. Pi is the famous number. So what is a primitive function here? This is the sum of two functions. So if I want to find a primitive function or an antiderivative, I have to do this one and that one separately. But which formula is relevant for the first part? Yes? Yes, the second row. So that's a math 3C problem. Both of them are actually. But this one is this formula. How do you recognize the difference between this and that? Here, x variable is in the base, a, the constant, is in the exponent. But here, x, the exponent is variable, but the base is constant. So here, x, the variable is in the base, the exponent is constant, so what happens? It becomes 1 over pi plus 1, x to the power of pi plus 1. Yes? But what happens for the other one? The other one is this formula. If you compare this one with that one, what is k? K is 1. What is a? A is pi. So it becomes plus 1 over ln of a, which is pi, and then the function repeats itself. So that's the answer. Okay, number 3, I write and wait for you. Okay, so f of x equals to e to the power of 2x. Let me write 3x here, and then I have e to the power of 2x plus e to the power of minus 2, let me write minus 4x to the power of 2 plus e to the power of x. I will wait for you a little bit. Should we do it? So how should I do that? Yeah, we have to expand and then simplify, and then there's one single formula involved. So it's also a math 3C problem, you know. So f of x is equal to what? To expand, I have to be patient, write this one first. Let me see if I'm recording, yes. And then I raise this one to power 2. The first one squared is e to the 4x plus 2 times the first one times the second one. Can you do it in your head? What happens?
Minus e to the power.
Yes, because when you multiply this by that, the exponents are added, so it becomes minus 2x. So I have a 2 times the first one times the second one, it becomes this. And then finally the second one squared is minus 8x, and then e to the x at the end, but I have to multiply this in as well. So f of x becomes e to the power of 7x plus 2e to the power of what? X plus e to the power of minus 5x, and finally e to the power of x. So it's a bunch of functions, but all of them uses this formula. Okay, so let us not waste the time. So what is the capital F? An antiderivative. F of x is equal to what? 1 over 7 e to the power of 7x. The next one is minus 1 over 5 e to the power of minus 5x. The next one, oops, I forgot to write this one, sorry. This one is what? 2e to the x. Okay, doesn't matter if you just interchange them. And the last one is, we can write just 3x. Yes, you are right. Because this e to the 2e to the x and e to the x is just 3e to the x. So I just write 1, 2. Yes? Okay, so what do you expect me to teach you next? Sine and cosine. These are the functions that we add to this. And these are the only ones. So we completed, but of course, if you go to a technical university, you will still complete this table. Okay, so the one thing that I want to ask you, I want you to describe for me the formula yourself before me writing it. If I give you sine x and I ask you to differentiate, what do you get? Cosine. Okay, but now be careful. If I give you cosine and I ask you to antiderivative, what do you get? Sine. Okay, so antiderivative or primitive function for cosine is directly sine without any minus signs. Okay, but if I give you cosine and I ask you to differentiate it, do you remember there was one minus sign involved and this becomes minus sine x. So if I go backwards, antiderivative of minus sine x is cosine x. Okay, but what is the antiderivative of sine x itself? What? Minus cosine x. Yes, that's it. It's minus cosine x. In other words, if you don't like this method, I am asking you to give me a function whose derivative is sine. You cannot say cosine because the derivative of cosine is minus sine. To anticipate that minus sign is coming, you put a minus sign to cancel that minus sign which is coming. Yes? So that's it. So I go back here. But then let me ask you one more question because the formulas are more complete than that. If I have a factor in the argument, then what happens? If I give you sine 2x and I ask you to differentiate it, what do you get? The chain rule becomes involved, yes? It becomes what? It becomes cosine 2x, but you have to multiply by the derivative of 2x itself, which gives you a factor of 2. Of course, if I give you this and ask you what antiderivative is, you will get this back. But if I just write cosine 2x and I ask you what is the antiderivative of cosine 2x, what do you say?
1/2 sine.
So you put a 1/2 to compensate for the coming 2. So you just write 1/2 sine 2x. Yes? In other words, why this is true? Because if you differentiate this, you put 1/2 aside, and then you take the derivative of this one, which is cosine 2x, but multiplied by the derivative of 2x2. So you put this 1/2 there to cancel the coming 2. Yes? That's it. So if I want, can you tell me what happens if I have sine kx here? What is antiderivative of sine kx? A function whose derivative is sine. It should be minus cosine. Do you agree? Because the derivative of cosine has a minus sign, so I put a minus sign to cancel the coming minus sign. But it also gives me a factor of k, so I put 1 over k to cancel that factor as well. Yes? So there is no enough space here, so let me write c here, and immediately let me write this formula as well. So it becomes 1 over k sine kx, and then plus c. Sorry for the mess there. Can you read it? Cosine kx, 1 over k sine kx. Sine kx is minus 1 over k cosine kx. Okay, so now I will give you some examples that we can use these formulas. Okay, and the lesson for today will be finished here. But this is a very important lesson because what comes next relies on this notion of primitive functions. If you want to do calculations, you have to be very good in finding primitive functions. Okay, so let me write again an example. Determine a primitive function. So number one, so let me write this one for you. So f of x is equal to minus 2 cosine 3x plus 5 cosine 7, sine 7x. That's it. I want to find a primitive function for this. Yeah, it is very clear what to do, yes, because now these two formulas are involved. So capital F of x becomes what? What about this one? You see the formula for cosine is there. There is a minus 2 here. But this one follows the last formula by giving the rule of k, the rule of k to 3. So it becomes 1 over k, so it's 1 over 3, but a sine of this function, of this angle. For the next one, I have a 5, but I want to use the formula for sine. It is minus 1 over k. In this problem, k is what? 7. So what happens? It becomes minus 1 over 7, and then it becomes cosine. And because I want to find a primitive function, so I don't need to write a constant c, but let me simplify this a little bit. So this becomes, not simplification, I'm writing it properly. So it becomes minus 2/3 sine 3x minus 5/7 cosine 7x. Simple, yes? Okay, so let me give you a little bit, because in the book and in the national exam, they have some a little bit harder examples of this type. So let us just practice this. For example, number 2, what do you think will happen for this function? F of x is equal to, let me write one simple one first. So 3 sine x over 5. Just this one. So what should I do? Yes?
Use the first formula for sine kx, and k is 1 over 5.
Yes, k is 1 over 5, yes, because this is, I hope that everyone at least this level, I shouldn't explain these things too much, but x over 5 is 1 over 5 times x. So now if I write this in my head, so f of x is 3 sine 1 over 5x. By comparing this with the formula that we just learned for sine, you immediately realize that 1/5 is playing the role of k. So what happens? Capital F, this is a multiplicative constant. I copy and paste. And then I have 1 over k. K is 1 over 5. And then this becomes cosine. This is sine, so it has a minus sign there. And then it becomes cosine of 1 over 5x. But you shouldn't leave it like this. Minus 1 over 5 is just minus 5. So f of x becomes what? Minus 15. And I prefer to write it back in the original form. Of course, it doesn't matter that much. Yes? Okay, now let us solve a little bit harder ones. Let me go to this board. Okay, so this one, let us increase the level of the difficulty little by little. Okay, so f of x, I will wait for you, okay? Sine 2x plus cosine, let me write minus. It doesn't matter, of course. Minus cosine 2x, and then to the power of 2. I will wait for you, okay? Yeah, expansion. Expansion will work. So that is, you need to think. So you have to use your trigonometric knowledge a little bit here as well. So this becomes, because you know that this is not in the table. That's the reason I have to change the form. So f of x becomes the first one squared minus 2 times the first one times the second one plus the second one squared. Yes? Okay. And then, still I consider it a hard problem, yes? Because what should we do?
Sine squared plus cosine squared.
This one and the last one is the very famous trigonometric identity, yes? Sine squared of an angle plus cosine squared of the same angle is always 1. Okay, but let me ask you one question. So instead of these two, I write 1, and let me just, for the time being, copy and paste the middle term. I have seen still some of you take this one and that one separately. And both of them, you can do this. You can find a primitive function for this one only using this row, and a primitive function of this one using the next row. But is it a good way to do it? Why not? Because I told you what? A primitive function of f times g is not equal to primitive function of f times primitive function of g. So that is not working. So even if you know this one, I agree, you know it from the table, you know this one from the table, but you cannot do them separately. So then what should we do? Yes, this combination, I told you, you have to train your memory about this combination in trigonometry. Sine of an angle multiplied by cosine of the same angle is a famous combination in trigonometry, and it is related to the sine of the double angle formula. Okay, so what should I write here? And then I have also the 2 there. So I go one step further. I copy and paste 1. Instead of minus, I want to use this formula. So 2 sine theta cosine theta is what? Is sine 2 theta. Yes? But here 2x is playing the role of theta, so it becomes minus sine 4x. Now everything is ready. So the a primitive function is what? A primitive function for 1 is x. A primitive function for sine is negative 1 over 4. That negative will cancel this negative, so it becomes plus. K is 4 in this problem, and sine becomes cosine. So I hope that you could get this answer right. Yes? Okay, there is another one which is in the book. I want you to know. So I will put a star on it, not because it is hard, but you need to think in this way.
What level would that previous question be?
Pardon?
What level would that question be?
I might say that is A level. Yeah. So you never know, actually. These are subjective things, you know. But anyway. So the next question, I start with a simple one, which I saw in the book in one of the exercises. So the question is number 4. Let me ask your opinion about it. Let me put the simplest version of it here. So f of x, for example, I just write sine x to power 2. Okay? And let me put a star here, not because it is hard, because I want to make sure that you remember it. Okay. You see, we are a little bit in trouble here because we do not have any formula for sine x squared. And if I write it as sine x times sine x, it will not help me because of that red formula that I crossed up there. So what should I do? Of course, it needs your memory a little bit. Because sine x squared, I told you when I was teaching trigonometry, sine x squared involves in 2 formulas. One formula is the famous formula, sine x squared, yes, plus cosine x squared is equal to 1. This formula does not help you, because if instead of sine x squared, you write 1 minus cosine x squared, then you have the same problem with cosine x squared. Okay, so that's not going to solve. But I don't know how many of you remember, I told you that this combination also appears somewhere else. There are 2 places in trigonometry that sine x squared becomes involved. One of them is the famous formula, and the other one is where? Yes? Cosine double angle. Yes? So, and then of course I don't expect you to remember the details in the cosine double angle, but if you don't remember any connection at all, then why you should go and look for it? But at least if you remember that sine x squared and cosine x squared both appear in two places, either this standard formula or the double angle formula for cosine, both of them. Okay, so if you know that and then you go to check, you will find a formula for cosine 2x which is equal to what? Three formulas. Do you remember? One formula was this. You don't need to remember, but you need to remember the connection, and then you can look it up. And then it becomes 1 minus 2 sine x squared, and the other formula is 2 cosine x squared minus 1. So remember, sine x squared and cosine x squared sometimes always appear, of course, here and here. Sometimes this is useful to know, sometimes this is useful to know. Okay, so now I want to use this part. So what I will do, I would say that, okay, 1 minus 2 sine x squared is equal to cosine 2x. Yes? But I am looking for sine x squared. So what should I do? I move 1 to the other side. It becomes cosine 2x minus 1. And then I want to get rid of this minus 2. I divide everything by minus 2. So it becomes sine x squared is equal to minus 1 divided by minus 2 is 1/2 positive. And this one becomes minus 1/2 cosine 2x. That's it. Yes? And now this is the formula. So I have to use here. So this is why I put double star here to make sure that you remember it. So capital F of x is what? A primitive function for this. But this one is equal to this. So I take a primitive function for 1/2, which is simply 1/2 x. And a primitive function for cosine 2x is the last row in that table. So I have a minus 1/2 here as a constant. And then 1 over k, which is 1 over 2, goes out. And then this becomes sine 2x. But 1 over 2 times 1 over 2 is 1 over 4. And that's the answer. Okay, so remember, if the second power of sine, the second power of cosine I will not solve, that's more or less the same story. Do you agree? Because for the second power of x, which formula is useful? This formula. Yes. So this is something that you need to remember. Whenever the second power of sine or cosine appears, and you are supposed to find a primitive function, you need to remember cosine double angle formulas. Is that okay? Yes, that's it. So let me add one more formula there, because do you have any idea which formula I want to add there? It's a little bit artificial formula. I don't like it, because what is the next step? What is the next natural formula coming after this? Tangent. Do you know how we did it last time? Do you remember?
Sine divided by cosine.
What?
Sine divided by cosine.
Yes. How we did it? Using this formula. Yes. So okay. So you have forgotten. I don't know, this is not in the formula sheet, but it doesn't mean you can't do it. So you can put the formula of tangent kx, which is the next natural one coming. And it is in the book, in the exercises. Okay, so we did it last time. So I told you find a primitive function for tangent x. Do you remember? We wrote it as sine x over cosine as usual. But then I wrote it as minus sine x over cosine x. Yes, minus cancels out. And then the reason I did this, because I can write it as cosine x. instead of minus sine x, I write cosine x derivative. Is that right? So then it becomes u prime over u with a minus sign. So primitive function becomes what? ln, a minus sign, ln of cosine of x. Yes? You can have the same story for tangent kx. So what is tangent kx? Tangent kx is sine kx over cosine kx. What adjustments do I need to do now? The same idea, okay? So I want to write this as cosine kx, and I want to write it as cosine kx prime, okay? But then I have to do some adjustments, because if I ask you what is cosine kx prime, it becomes minus k sine kx. So to adjust that, I have to divide by minus 1 over k. Okay, and that is the same story now. So f of x this time becomes minus 1 over k tangent of kx, sorry, ln of cosine kx. I mean, these are done in exercises, but you don't have them in the formula sheet. So remember, it doesn't mean that it's higher than the level of Math 4. No, it is Math 4, but it is not in the formula sheet, okay? So if you want to go further, you can also write tangent kx here, and that's the formula. But one thing which we can talk about is, do you remember what was the derivative of tangent of x? Okay, so, okay, so the derivative of tangent of x is 1 over cosine squared x. Okay, so if you go back, we had this formula before. So what does this mean? And this is sometimes might be they can ask you in the national exam. If you don't remember this at all, it would be very tricky. So if I ask you what is a primitive function of this very particular combination, it becomes tangent of x. So if I give you a function of f of x to be 1 over cosine x squared, and I ask you what is a primitive function, what is a primitive function? Is tangent x. Okay, but this is very artificial, so that's why it is natural not to put it in the table, because you might ask why this is useful to put 1 over only cosine x squared in the formula. It is not that natural to put it in the formula sheet, but this is possible because this is in chapter 2. They might ask you to give a primitive function for this. Then it means that if you don't find it in the integral table, you will go to the derivative table. In the derivative table, you see this combination, and based on the knowledge of what is the primitive function, you can find what is a primitive function. Okay, so I just want to draw your attention to this. Might be next time I give you some warm-up problem using this idea. So tangent kx could be in the table, and it is natural to put it in the table, even though it is not, but this is at the level of Math 4 in the book. But this combination can also be in the table, but which is not. So remember this. Okay, any questions? Okay, thank you.